Creating a table, permanent or temporary, in any database system is an easy task. The SQL construct is so simple that even an entry-level data engineer can learn in a few minutes. So why do we need to talk about the database schema or table creation in the Snowflake? And why do we need to understand its container hierarchy? Data type in Snowflake look very similar to Oracle or SQL Server, or they are very different. How to use Snowflake extended SQL while creating a database or schema or table to enable the timetable features. How constraint works in Snowflake or it doesn't work at all. You will see all of them live in this episode with detailed explanation and understand the true difference what Snowflake brings. And as a Snowflake practitioner, you must know before you get into the data development with Snowflake. Don't assume what you know is sufficient to work with Snowflake. You might be missing a lot of powerful feature which could save a lot of time and money for storage as well as for your compute. So stay tuned until the end of this video and learn everything about database schema, table and container hierarchy in Snowflake and Snowflake way. So let's jump into it. Hello and a warm welcome to my channel Data Engineering Simplified, and this is Snowflake video series, a real jumpstart course for data professional. In the last 6 episodes, we have already covered a lot about Snowflake, including its architecture and unique feature. This episode will focus on Snowflake container hierarchy and table creation, including permanent, temporary and transient table alongside data type and how to load the data from internal as well as external stage. I hope you have been enjoying this visual guided tour on Snowflake. So let's start with Chapter 7. So what is covered in this Chapter 7? Chapter 7 is more hands-on chapter which give you the concept of container hierarchy, and then we are going to practice database creation, schema and table along with many other concepts like time travel features, how to load the data into a permanent or an external table. Before we proceed further, I have a small announcement to make. If you really want to master Snowflake Cloud Data Warehouse, I would recommend you to look into my channel's playlist. The playlist section includes SnowPro and Advanced Certification Guide, mock question series, important SQL functions, Snowflake connector series, Snowflake features and limitations, and many more real-life hands-on videos. By watching my free video series, many data engineers, leads, and architects, and even managers are getting certified in SnowPro Core and Advanced Certification. And the success rate is very high. I'm not lying. Just look into the comment. You don't need to buy any expensive courses. Just subscribe to my channel and I guarantee that you would easily learn this technology and get certified in just few weeks. So one small favor, if you are learning from my channel and my content, please hit the like button, and this gesture will make me super happy, and YouTube will also promote this video to other audiences who are willing to learn the Snowflake Cloud Data Warehouse. Let's go through the tree map of Chapter 7, which helps us to know what all we are going to learn in this chapter in detail. So we will primarily look into the container theory, what is the container, what is account level object, and what is a database level object, followed by the object identifier. During the live demo, we will see how the object identifier works. We will also see different data types starting with number, string, boolean, timestamp, semi-structure, binary, and unsupported data types. We will also quickly cover the table types and we'll really practice them. We will also see the column constraint, whether not null, unique key, foreign key relationship, and default value. We will also quickly load the data via insert statement via web UI. SnowSite does not support the data loading through its interface. We will also try to create the table structure via select as a statement. We'll also use the copy command and try to load structure and semi-structured data. We will describe the table through the describe function and get DDL function. We also see the table storage cost, and we will also try to play with the external table. This is how the overall tree map looks like. If you want to access this tree map, you can refer the link below. So let's understand the overall container hierarchy. As we know, a Snowflake instance is nothing. So a Snowflake instance starts with an account. An account has different objects. So account holds all users, all role, warehouses, resource monitors, integrations, databases, and shared object. So these objects are account level object. Under the account, you can have many databases, and each database can have many schema. And then this schema can have tables, external table, view, stored procedure, sequence, stage, file format, pipe, stream, task, and UDF. So this is how the overall container hierarchy looks like. So whenever you create a table, whether it's a standard table or external table, it has to be part of the schema, and the schema belongs to a database, and database is an account level object, and each Snowflake instance itself is an account, and that account may belong to an organization, and an organization can have many accounts. You are not allowed to access tables from one account to another account. It has to be accessed through the shared object, and this is a very important point. And this diagram helps you to understand whenever you create a table, whether it is permanent, temporary, or a transient, it has to be within the schema that itself is a virtual container, and each schema belongs to a database, which is another virtual container, and each database is a part of an account. This is how the entire container hierarchy looks like. Let's go into the live demo where we are going to see how to really play with the table objects. So here I am in my Snowflake instance, and I have this worksheet open for you. If you want all the SQL script, please refer the link below in the description section. Let me shrink this object browser. So let me set the role as a system admin, which I can also do through this context menu. And let me create my first database. This is very simple. I am going to create my database called MyDB, and the SQL construct is create database, my database, followed by the command. So the moment I select one of the statement, since SQL highlighter is switched on, all the statement which is going to be executed will be highlighted. I'm not going to select anything specifically. I click on the run button. My database is created. I can also command called show databases, and so this is my database called MyDB, and this is how you can list all the databases. If you really want to specify the filter statement, like statement is there, and this will bring only those entry which matches with my like statement. One important thing to notice here, whenever you create any object into the Snowflake, if it is not with a double quote, it automatically takes the uppercase. As soon as we create the database, my current database is changed to MyDB. Let me verify that with this statement. So here you can see my current database is MyDB, which I have just created. Now let's create a schema. The construct is very similar. The way we created a database, I will create a schema, my schema, followed by my comment. I have selected this statement. I click on the run button. So my schema is created. So it has listed all the schema, including my schema, and this my schema belongs to database MyDB, and the owner is system admin because I have chosen the role system admin. Now this thing I can also perform by going to the database tab. So let me go and show you. So here I can also click on the create button, and I can really give the database name including comment. I can copy the SQL statement and use it for later. So this is how I can create the database. Once I go inside my database, I can also create a schema. So I can click here and I can click on the create button to create a schema. So this is how you can use web UI to create database as well as a schema. Alternatively, if you are familiar with SnowSite and you can create your database, one of the important thing with SnowSite that along with basic information, it also try to show many additional information in a more visual way. And if you really want to understand more about SnowSite, please go back to the chapter 5, and chapter 5 covers SnowSite in detail. Going back to my worksheet, always remember whenever we have to list anything, I have to use show followed by name of the object type. For example, show schemas, show databases, show tables. It is a pretty standard SQL construct in other databases too. Once I complete creating my schema, my context function automatically changes. Let me re-verify that. I can see it here. My current role is system admin, my current database is MyDB, and my current schema is my schema. Though I have not specifically selected MyDB and my schema, however, the moment I have created my database and my schema, the context has changed automatically. Now I am explicitly changing my database and schema. So this is my first statement I have selected. Now my schema and database both are changed, and let me rerun that. I have a habit of always changing my database schema and role and revalidating it. We have covered this in detail in the context function series. Now let me show you how we create a table, and this looks very simple the way we create a table in any other database. Here I am just creating a table called my table. I am giving the first field as an ID with auto increment. Any integer value is defined as a number. If you want to define number as a decimal or a float, you can specify this way. You can also alternatively use keyword decimal. So number, decimal, you can use interchangeably in Snowflake. If you really want to specify int, Again, you can specify int or integer. Snowflake has really taken this kind of vocabulary. So if you are migrating from SQL Server or Oracle or Teradata, you don't have to change your SQL script. You simply copy your DDL statement and paste it here, and your DDL scripts are ready to run within the Snowflake. Let me create this table. So my table is created, and how can I describe my table? So I can use describe table, my table, and I can see that this table has 7 columns. First column is ID. ID, everything is number, even though I have specified different data types, but everything is number. If you do not specify the size of the number or integer, automatically it takes 38. Wherever I have specified the size of the number, whether it is decimal or without decimal, it has taken that particular specification. Here we can see all the numbers where I have given the specification. This specification has been captured. Wherever I have not given the specification, it has taken 38 by 0. And if I have an identity column, I can see the identity column start with 1. This is also called sequence, and none of them is a primary key, none of them is a unique key. There is no null check I have put, and there is no expression I have given, there is no comment I have given, and there is no policy specification I have given. So this is how you can describe a table. Now there is another way that if I have to extract the DDL statement, because all the data set which I got it from the table is showing me number, but if I really want to understand how the DDL looks like, then I can use a function called getDDL, and getDDL takes 2 parameters, the type of the object and the name of the object. So let me run this statement for you. Now I got how the table is created. I have to click on this link, and this is how I get my entire DDL statement. A very nice feature. From here you can copy and paste it wherever you want to do that. Now one important thing to notice here. So if you look into my DDL statement, here it is just num, here it is int and integer. But when I generated the DDL statement, it has really given me the 38 as a default. So this is one minor difference which you have to take care and make sure that you understand these small differences while using this getDDL statement. Let's move next. So we have understood how to describe a table and get to know about each of the column. We have also understood how to use the getDDL function to get the DDL of a particular object. Now let's understand how to insert, and this is also pretty standard. So since we have one increment column, I have specified all the field name here followed by all the values. So I got one record inserted. If I have to insert multiple record, I can really follow the values, and I can follow this kind of construct to insert multiple rows in the table. This insert 1 row, this insert 2 rows. Let me run the select statement. Now I can see the 3 records got inserted, and this identity column generated the ID values automatically for me. Now there is one concept called fully qualified name. So instead of referring, since my context is already selected like MyDB and my schema, it is very easy for Snowflake to understand this my table belongs to my database and my schema. However, when you are operating under a condition where you have a multiple databases, multiple schemas, and you are having a join query, and you would like to specify the table name with fully qualified approach, then you can also refer mydb.myschema.mytable, or you can also use double quote across the entire table path, or you can use individually. Let's understand the text, how the text field works or Varchar field works within Snowflake. So I'm creating a table called my text table, which also has an incremental column, and I can specify Varchar, I can specify char, I can specify string, and I can specify text. So these all variations are allowed in Snowflake, and I'm going to create this table for you. Let me describe this table first. And what I see, so if you have not specified the size of the Varchar, then automatically it will take 16 MB. Wherever you have specified the size of the Varchar, then it would take that length. If you are using character, it will automatically take 1 character. So this is how the Snowflake understand the DDL and translate into the actual table object. Very important thing to remember, if you are creating a column which is only storing a small amount of data set, I would recommend you to use a specific length. However, Snowflake is smart enough to do the optimization, but this optimization only work with Varchar or string. This optimization does not work with a float. And if you have not specified, if you are not storing a floating or decimal data and you are only storing the number values, you end up incurring more and more cost for that table storage. So very important thing to remember. Now let me insert a record. Let me run the select statement. So works pretty well. Now I'm going to create a table which has only a Boolean value. So a table with Boolean value is created. Let me describe this table for you. When I describe this table, Boolean is having a Boolean type, and I have just given something called number and s. You can also insert 1 or 0 or a particular string value to the Boolean column, and it will automatically translate into true and false according to the 0 or non-zero value. So here I am inserting 3 rows. First is true, second is false, third is null. And let me see the data. So wherever I have inserted true, it has taken true with uppercase. Wherever I have inserted, so true and false is taken as an uppercase. Null is a null. So null is not false here. Null is a null value within the Boolean. So make sure that you understand this concept in Snowflake. Now let's understand the timestamp and how the timestamp works. And here I have used the default values. So you have a date field, you have a time field, and you have a timestamp field in Snowflake. Let me create this table. Let me describe this table. How does it look like? So date has a date. If you have created a time, it will take the time with 9 precision. And if you have created a timestamp, it will also take the time with a 9 precision unless otherwise you have specified. All the time is stored with UTC or no time zone. Even though you have inserted a data set with a time zone, internally it is stored with no time zone. Very important thing to remember. And why it is like that? Because Snowflake is a cloud-based instance. You might be accessing your data set at a particular time zone. However, the Snowflake instance is running either in Europe or maybe in America or Japan or somewhere else, right? So whenever you are dealing with a timestamp, make sure that you understand the time and timestamp field appropriately. Now let me insert one record, and this record will only insert the current date, current time, and current timestamp. And let's see what result does it bring. So the first row I inserted with all the value. The second I inserted with the time. Let me fetch the data for you. So I can see that since the default value has been given, both the rows come appropriately, works perfectly fine. Now Snowflake allows you to change the time zone. In other databases or data warehouse system, you might not be allowed to change the time zone. However, Snowflake allows to change the time zone for your session. This time zone is changed only for your session and not for everything. And when I talk about a session, only for this worksheet. If you open another worksheet, you can have a 2 different time zone within the same instance, Snowflake connection for 2 different worksheet or a session. So now let me run for you. And so right now I am in America, Los Angeles time zone, and let me insert another row. Let me pull the data. Here I can see everything works perfectly fine. If I go to the Japan time zone and I insert a record here and I insert another record here, select the table, this is how it looks. So you see for Japan, the data set is very different. So you can also use the timestamp output format to change the output format according to your need. So this is just a quick summary how the date, time, and time stamp field works and how you can really change when you are building ETL solutions using this time zone and time zone output format. Now let's understand uppercase, lowercase, and a mixed case while creating the table. So I am creating a table called my case table. I am using all lowercase and it is having only one field. So my table is created. Let me describe this table. So this has one field and it is a varchar. When I say show table, it shows my table. One important thing to notice, it has created the table with uppercase. Now when I'm trying to create a table with uppercase, it says the table already exists. If I try to create a same table with mixed case, it says it is created, right? So one important behavior to notice here. Now what if I have to create a table with having a space between the names or with mixed case? So here I am having another example. So I can, whenever I have to create a table name where I have a space or I want to really make sure that table name is created with mixed case, uppercase, and lowercase, then I have to keep the table name within the double. Let me run this SQL statement for you. So all these 3 tables got created, right? Let me run the show tables. Here I can see my tables is created. Now all these 3 tables are created. Perfectly fine. Now when I describe this particular table, because in this table I have created two fields with the same name, but since they are within the double quote, they are identified uniquely. So let me run this describe my table. So when I describe this table, I can see my field and my field both are available, and this is a lowercase and this is a mixed case. So this is how the lowercase, uppercase, mixed case and double quote concept work in Snowflake whenever you are creating any object, not only the table. Now can I create a table as a select statement? Yes, very much possible, very standard across all the databases. So I am creating a table called myCTAS as a select statement. Let me run. So since I have already created a table, now this table got created. Let me do a select statement. So I got all the data from my table to my CTAS table. I can also insert record using select statement, and the statement is pretty straightforward. Now 3 rows got inserted. Now this table will have 6 rows. So yes, I can see 6 rows, perfectly fine. We can also load data through the web interface. Okay, so it's not that I can only load the data through the insert statement. I can also load the data web interface, and let's how we can do that. There is one limitation that through the web interface you can only load data up to 100 MB. Any file which is above 100 MB, you cannot load the data. So whenever you are playing with a sample data set for your testing, you can always load the data through web interface. So to load the data through the web UI, we can click on the database icon. So this screen comes up. Here we are going to load the data in a table which belongs to database called MyDB. We have to click on that. Before we load data to table my table, I have to create a file format which tells Snowflake the file which I am loading, how it has to be translated and parsed before the data is loaded into the table. So I click on this option file formats, click on create button. Since I am loading a CSV file, I simply keep the name of the format is my CSV, and I leave those options as it. Click on finish. So my file format is created. I go back to the table tab. I click on my table and click on this button load data, and I simply click on next, next, next. You can also choose different option if there is any error, how my loading would behave, whether it will stop loading or it will continue loading. For now, I will just choose continue loading valid data from the file. I have just 3 rows in my CSV file, and let's see how does it work. Let me click on the load button. If you really want to see how the SQL looks like, you can click on the show SQL button, and it would primarily run a copy command. How this copy command looks like, it says copy into my database, my schema and my table, and here you see that fully qualified name has been specified, where this is my database, this is my schema and this is my table. So let me load the data. First, data is being encrypted, and it clearly says that total 3 rows have been parsed and 3 rows loaded. And if I refresh, since it got the data recently, it shows that 6 rows are loaded, total size is 2 KB. So this is how this works. You can also track from the history tab what kind of command has been executed. So I can clearly see that this to command is executed, which loaded the data into the table. Let me go back to the worksheet again. So we have covered how to load the data through the web UI. Now let's see how the constraint work in Snowflake while creating a table. So this is a table which is called my constraint table, and I am having empPK with primary key and first name, last name with not null, flag called by default active, and I am having a unique column called unique code. Okay, let me create this table. I am inserting 2 rows into this table where my primary key is still 100 here for both of them. For any other relational database or data warehouse system, probably this is not possible, right? But let's see what happens when I try to insert this 2 record into my constraint table. Both the rows got inserted, and let me select the table. And I can see, even though my empPK is a primary key defined as per the DDL. So when I run the select statement on this table, I can see the primary key is still a duplicate, and the unique code is still duplicate. Okay, so Snowflake says that it allows you to specify the constraint, but it does not enforce the constraint. A very important things to remember. Now, what happens when I try to insert a record where not null is defined? It will end up with an error. So Snowflake only enforce not null constraint. All other constraint within Snowflakes are just as a definition, but it does not enforce during the execution. Very important point to remember. Now I am running the below insert statement again and let's see what happens. So here, wherever you have not null column, the Snowflake will throw an error during the insert or copy statement. So if you have a PK or uniqueness, only the not null is applied, but primary key and uniqueness is not being applied. You have to really do it during your ETL transformation time. Now let's see how to load the data from your local environment if the data size is more than 100 MB. In this case, we are anyhow not trying with a large data set. I will try to load the same data set again. And for that, what I have to do, I have to use a CLI tool called SnowSQL, and I am going to connect it through CLI command. I will put the data to the stage, and for that I will create a stage object first. So let me create a stage object first. I will go to the database tab and I will go to the stages. I will click on a create button. I will create an internal stage here. So my stage is created. I will go back to the worksheet. And here I will change this name, my stage. Okay, let me connect to SnowSQL. I am connected to my Snowflake instance through the SnowSQL. Right now, no database and no schema is selected. Let me switch my context. So my current database is MyDB and my current schema is my schema. Let me use the put statement to load the data to the internal stage. So here the command is that put followed by the file name and give the name of the stage. My data is loaded successfully and it says that the ch07.csv is loaded. It is actually compressed with gzip. Let me go back to my web UI. I can list all the files which are available in my stage. So once my data is available in the internal stage, I can really use a copy command and load the data. Before that, how can I see what data is available in the internal stage? So here I am just creating another file format called my format with this command. I'm using this SQL construct which will help me to read the data as well as display the data in a tabular format from internal or any external stage. So let me run this statement for you. And I can see the data which is available in the internal stage. Once I am happy with the data set, I can really load the data. For loading the data, first let me create a table called my stage table, a very simple, straightforward table. And I can first select, I don't have any record. Now I'm going to use copy into my stage table from my stage. As soon as it clearly says that 3 records are passed, 3 records are loaded, let me select the table. So I can see my table got populated. There are two ways you can load the data. Either you can use the web UI to load the data if your data size is less than 100 MB, or you can load the data through the put command through SnowSQL and then use the copy command from your web UI to load the data. So pretty straightforward. Make sure that you use a proper file format while loading the data. You can load the Parquet, you can load the JSON, you can load ORC, Avro, XML, anything this way. You can also use this SQL construct using a $sign to really understand how the data looks like before you can apply the copy command. Let's see what happens when you try to create a big table. And before that, I would like to show you how do you check the size of the table. So here we have Snowflake sample data. And if you go to any particular data set, click on the table. For example, I click on the order table, and on order table, it clearly shows that it has close to a 1.5 million record and the size of the data is 43 MB. If you choose a different schema and if you click on the orders table, you will see more bigger data set. So in this example, I am going to create a table using a create as statement. Okay, so since it is a big table, it took little time and it took almost 1 minute 7 seconds to load the data set. Let's go back to our object explorer and see how many rows are there and what is the size of the table. Here I go to my database and I can go to my schema and I can click on this. When I click on my cat's big table, it shows that it has 3.8 GB of data set and roughly 150 million record. So this is how it looks like. Now what I'm going to do, I am going to alter this table and trying to have data retention period as a 30 days. Now let's see the data set. How does it look like? I'm pulling first 10 rows and here I can see that it has a lot of order related detail and I'm going to work upon this order status column. So first let me understand how the order status is divided into entire data set. So I have order status P, O and F, and this is how the distribution looks like. What I'm going to do, I am going to update the order status O from, so what I'm going to do, order status is O from uppercase to lowercase. This will touch quite a lot of record, and let's see what happens. So roughly 7 million records got updated, and it took again a 1 minute of time. Now here I am copying this query ID. I'm replacing the query ID with this. Now first let's see, has it changed the size of the data, because we have given the retention period of 30 days, right? So I don't see that there is any change which has happened. However, if we look into this data set after 1 or 2 days, or if we apply some more update, probably the data size will change, because since we have applied a 30 days retention period, every update and every change has been recorded. Now let me run this group by command once again to see how the data grouping looks like. So I can see that everything is with lowercase. One interesting thing here, when I compare the web UI versus Snow site, I can go to the Snow site and I can really see the data distribution. Let me quickly show you. Here you can see how this database columns and everything looks like. And I can click on a data preview, and the data preview is appearing here. And it also says that it has 150 million rows and having a 3.8 GB. So it gives some more summary level information. I just go back to the worksheet. So SnowSite keeps adding different and new features, and here you see the execution details are being shown, that the number of record which is being read is constantly displayed. And since it has 150 million rows, it is also processing and creating a profile. One of the biggest challenge with the SnowSite that it is relatively slow compared to our legacy web UI. You can notice one thing, if your data size is very, very large, the profile doesn't work. However, if I go for a smaller data set, so for a smaller data set, it will show you the calculating stats. And once the data is populated, the stats will be visible here. We have covered this in detail in our previous chapter when we discussed about SnowSite in depth. You can see the link above. So let's go back to our legacy console. Since we have already updated a status column, if I have to go and understand that what has happened before, I can use the time travel feature using extended SQL, and I can say select count star from this big table before the statement, and this is the statement which we executed as update statement. And here I can check what is the count with order status O. I would not find any record because there was no small o. So with this statement, if I run this command, make sure that the before should come right after the table, otherwise this SQL syntax will fail with compilation. Now when I do capital O, because we had the capital O, and I would like to run this statement, and I got around 73 million rows. So this is how the time travel works, because when you apply the time travel with statement or at statement or at particular duration, you will get the historical data from the table. Now let's talk about the variant data. And before I really show the variant data, I will club the variant data with external data source. So here I am creating a table called variant data. Let me describe how the variant looks like. So it is a variant type having a name v, and it is a kind of a column null yes, so it can take null. Now I'm going to create a stage which is called NYC weather. Okay, once it is successfully, I have already executed this statement. So my external stage is already created, which is right now in S3 bucket. Now let me list what is the data set available in this S3 bucket. So I have total 61 rows in the bucket, and what can I do? I can really run this copy command and I can load the entire data set, which is in the JSON format. So you can apply file format type JSON, very simple way, or you can say type CSV if you do not have a file format, and you can run the copy into command to get the data. So let me run this command. So all the 61 rows loaded, and this is what the data which is being passed and loaded. If you have any error, you would be able to record the error from this table. Now let me run. How does it look like? So since everything is a JSON data, this is how it looks like. So you can really see the JSON data in a well formatted manner, and you can copy it for any further analysis. You can also create a view on the top of this table. And I want to see the view for a specific city. So this is how I can create a view. So let me select this view. So my view is selected, and let me run a select statement to see the data. So now my JSON data has been appropriately formatted, and I can really work like a normal table. So this is how your external data set can be loaded into a table which has a variant, and that variant column I can further write a view, and I can get the data in a table manner. If you have to create an external table on exactly the same JSON data set, what you can do, you can simply introduce a word external. So create or replace external table, and I can create an external table on the data set what is available into the external stage. And what I have to do, you must know how many columns are there, and you have to follow this construct to create an external table. Alongside, you also have to give few additional parameters like location. You can also set auto refresh true and false, and you can give a file format of your choice according to the data what is available in external stage. And this is how you can run the query on the external stage table. In the same way, we can also create a transient table and the temporary table. Only difference is that when you create a temporary table or a transient table, you have to use the keyword transient or temporary. And one important thing, Snowflake does not give an error if you create a transient table or a temporary table with the same name as a permanent table. This is one of the important thing to note for you. So if you have to understand what is the cost of your storage, you have to switch your role to the account admin. So let me switch my role to the account admin. Once I switch my role to the account admin, I would be able to see additional tab. Let me click on the account tab. From the account tab, I can see how many warehouses are active and how much credit has been used. I can also click on the average storage used. I have not created a lot of data set. Right now this looks empty, and the data size is also pretty small. And since I have created the data now, probably it will take a day or few hours to get it reflected. I can click on the database. So I can see how much database data is stored. I can click on the stages. I can click on the failsafe. So this is how you can see the storage cost, and you can clearly understand how the storage cost is being incurred in your account and instance. So we have covered pretty much about container, database, schema, and table as a part of chapter 7. We have seen the container theory, what all the account level object versus database and schema level object. We have seen the object identifier, how to really give the object identifier. We have seen the different data types for creating the DDL. We have seen, the table types like transient table, permanent table, and external table. We have seen the column constraint. We have really loaded the data through the web UI. We have loaded the data through the SnowSQL and using the copy command. We have also described the table through the describe command followed by the get DDL tabular function. We also have seen at very high level about the table storage cost, and we have seen how you can create an external stage and use the copy command to load the data. You can create a view, or you can use the external construct to create external table and again query the dataset. I hope you have gained a lot of knowledge with this theory cum practice session. So what we have learned in this chapter 7. So we have covered Snowflake container concept along with account level object and database schema level objects. Permanent, temporary, and transient table, we have briefly seen how the construct looks like. Data type and its limitation. So we have understood that what is the different limitation when you use the describe table, get DDL, and how the data type is being translated internally within Snowflake. We have seen briefly about the external table construct, how to load the data via web UI, what is the limitation and what is the limitation of SnowSite tool, how to describe database schema table objects. So what's the next chapter? New objects in Snowflake. Thank you for watching this Snowflake tutorial video series. If you have any constructive feedback or area of improvement or anything else, please share your comment. Please subscribe to my channel and press the bell icon to get notified on my latest videos and data engineering educational content. Please like and share the video. I have a disclaimer. Please read it through. Thank you and happy learning.